All right, folks. Well, welcome back. And um, let's take a look at this mess here. So let's pick up where we left off with yesterday, and let's take a look at this mess here that we have. But I think the point that I was trying to make to you yesterday is that you got to make sure then that you can take a very simple graph that we have here. So we started out with the simple velocity time graph in which we plotted the motion and the motion of two different objects here. And we should be able to take this graph, this information, and understand where it came from. Okay, and so what we're essentially doing is with what we did here, with everything here, is we kind of worked backwards. We took a look at this graph, and what we did was we tried to figure out then what was being observed that generated this graph for us. Okay, and so that's what we have here. We have an object. So we did the object that was represented by the blue plot graph here, and then yesterday we did the one that was represented by the red here. Okay, and so what the object did, and so make sure you keep this in mind. So there's our object. This object is still moving in one direction. It's moving in one direction, but it's changing its speed. And so we were looking at what happens here over the course of a 10-second time interval to see what this object is doing. So essentially what we did here yesterday is that we worked backwards. And if you can do that, you can better understand the information that's being presented to you on the graph here. Okay. All right. So make sure you come by and you see me about this. Okay. If you have any questions about this, what the information we obtained here, and then like I said, work it out and make sure then that you can continue to practice doing this. Okay. All right. Let's go ahead then and let's take a look at another graph. Okay. Let's practice this a little bit more. Okay. All right, so first of all, if you take a look at this graph here, this is a velocity time graph. So so this is a velocity time graph here, velocity plotted along the y here, time plotted along the x-axis. Okay, and hopefully you recognize then that we have 1, 2, 3, 4 different objects that are being plotted, that are being observed. Okay, so we observed 4 different objects and their velocity over a certain time interval, and we were able to project that information onto here. So the question then is, can you interpret what's happening here? So for example, with object number 1, okay, with the object represented by the blue line here, what is that object doing as it's moving? Okay, so what I'd like to do is we'll practice interpreting this graph a little bit more. Okay, but what I'd like you to do is let's answer some questions. Okay, let's answer some simple questions about this graph here first. Okay, and so I want you to take about a couple of 2 or 3 minutes, hopefully a little less than 2 or 3 minutes, okay, and answer these 7 questions about the graph here. Okay, so again, this graph here is plotting the motion of 4 different objects. Okay, so take about 2 or 3 minutes, answer these 7 questions. Okay, and then when you get back, we'll talk about these. We'll talk about these, and then we'll use these to interpret the graph, and then hopefully you can do fairly well with it. Okay, so go ahead, take a couple minutes to answer these 7 questions. Okay. All right, let's go ahead and let's go back here really quickly, and let's take a look at what's going on here first. Okay, so and then we'll answer the questions together. Okay. All right, let's take a look at object number 1. So the blue object first. Okay. So first of all, this blue object, okay, hopefully you recognize in that this blue object here is slowing down. How do you know that it's slowing down? Well, a couple of reasons. So we know that the object is slowing down. Okay, so okay, as it's slowing down, how do we know that? It has a negative slope. Okay, it has a negative slope, which means then the acceleration is negative. The acceleration is negative. The negative slope, remember, on a velocity time graph, okay, on a velocity time graph, the slope of an object, the slope is the acceleration. Okay, the slope is the acceleration on a velocity time graph. So we know then the object is slowing down for a couple of reasons. We know it's slowing down because it is it's going from a high velocity here down to a low velocity here with 0 velocity being down at the bottom here. Okay, so it is slowing down here. So that's object number 1. Okay, let's take a look at object number 2. Okay, let's take a look at object number 2, and we'll call B here too. Okay, so if you notice here, B is doing the opposite. First of all, B has a positive slope, so we see then that B is speeding up. Okay, it's speeding up, Why? Because the slope is positive, and if the slope is positive, we have a positive acceleration, then we know then the object's speeding up. So visually we can see then that object B is speeding up. Okay, so we see that. Okay, all right. So I'm sorry, let me go back here really quickly, and hopefully you notice here. So because A is slowing down here, because A is slowing down, the acceleration then is not constant. Okay, it is not 0 meters per second. It is changing. This represents then a constant acceleration. Constant acceleration, again, doesn't mean that it stopped. It could mean that it stopped, but it does not mean that it stopped. It means then that it just doesn't change the acceleration. And obviously, here we have an acceleration that is not 0. Okay, the acceleration here is negative, and we have a number to it because we have a slope here. Okay, so this is a constant acceleration that's non-zero. This is same thing holds true for object number 2, for object B. We have an acceleration that is also not equal to 0. Okay, it is constant. It doesn't change. And we'll talk about changing acceleration in just a moment. The acceleration is constant. It just doesn't change, which means then the object continues to speed up as opposed to this object, which continues to slow down. Okay, let's contrast that with object C. Okay, all right. With object C here, if you notice, the slope is 0. So for object C here, it is neither speeding up nor or slowing down. It's doing neither slowing down. It is just moving along. How do we know that? Because the slope then is equal to 0. Okay, the slope then is equal to 0, and if the slope is 0, then the acceleration then it's going to be 0 meters per second squared. Okay, so here we have constant 0 acceleration. There's no acceleration here, but make sure you keep this in mind. The velocity here is not 0. The velocity if it was 0, it'd be down here. Okay, so if the object is not moving at all, okay, then you can imagine then this line would be right on the x-axis here. That would be constant acceleration, okay, because the acceleration changed, but in that case, then the velocity would be 0. Here we have constant acceleration because the acceleration there is no acceleration, okay, constant, and this is constant 0 acceleration, which means then it neither speeds up nor slows down, okay, which is different from the first two cases where the acceleration was not 0, okay, which means that the velocity, the acceleration, that you have an acceleration, and so the velocity constantly changes. Here, the velocity does not change. Okay, that's what we have there. Okay. All right. And so with that said, let's take a look at the last one. Let's take a look at the last one and see what it's doing. Hopefully, if you look at the last one, then an object D, for object D, then hopefully you recognize then that because this has a positive slope, this object is also speeding up. Okay, it's also speeding up. Okay, which means that it has a positive. If you see that it has a positive slope, which means the acceleration is also positive. And if you notice here, the acceleration then will not be equal to 0. Okay, so this is all we have obtained so far from this particular graph. We can look at each of the 4 objects and decide then whether it's speeding up or slowing down. Okay, and if you notice in each case here, and I'm going to write this in black real quick. In each case here, the velocities are always positive because we're on the positive side. Okay? In each case here, the velocities are positive. Okay? Here, the signs are velocity is positive, acceleration is negative, slowing down. Here, velocity is positive, acceleration is positive, speeding up. Here, velocity is positive, but there's no acceleration, which means then the velocity stays constant. Here, the velocity is positive, the acceleration is positive, again, speeding up. We can obtain all that information just from looking at this graph right now. Okay, so please make sure then that you can do that because you need to be able to do that first before we go on and answer the questions. Okay, so let's go ahead and answer the first question here. Okay, and the first question is, how many objects are being represented? Okay, so let me go ahead and do this here. Okay, so I'll just answer the questions here for you. The first question is, how many objects are being represented on this time graph? The answer is going to be 4. Okay, so that's question number 1. Okay, so please make sure you write down the answers to the questions here. Okay, the second question then is, what are the speeds of of each one of these objects at the start? Okay, so at the start then is here. This is where time is equal to 0 seconds. Okay? At the start then, hopefully you recognize it at the start. Okay, object A, object D and B, its velocity is 0. We can say that for certain, okay, because they start out at the origin. Okay, so we know then that objects B and D are at velocity 0. That means that they start at rest. So they are at rest to begin with. And how do we know that? They start out at 0 here. Okay, we know then at the start then the velocity of object C is not equal to 0 because it's not on the origin. So it's moving already. So you can imagine this. As soon as you start the stopwatch to start recording this here, recording the time, this object is already moving. It's already moving. Same thing holds true for this object here. Its velocity is also not equal to 0. It's already in motion, and so make sure to understand. We know that the objects will be will have a velocity of 0 when it is on the origin. Anything above the origin or anything below the origin. We'll talk about that hopefully today as well. Anything below the origin means then that the object has a velocity. It is moving. It's either going to be moving in the positive direction or in the negative direction as well. Okay, so make sure you keep that in mind. So that's answer to question number 2. So for objects B and D, the velocities will be 0. For objects A and C, the velocities are not equal to 0. Okay. All right. Let's take a look at the third question. Okay. The third question is, who is moving at a constant speed? Okay. So object C. Object C is moving at a constant speed here, and we already did this. How do we know? The slope is 0, and therefore the acceleration is 0. Meaning then that the velocity doesn't change. It means then the velocity here, the initial velocity here, is going to be equal to the final velocity here as well. And if that's the case, then the change in velocity has to be 0. Okay? And if the change in velocity is going to be 0, then the acceleration has to be 0 meters per second squared. And that's how we came up with this value here. Okay. And then also the slope is going to be 0. Okay. All right. That's question number 3. Number 4, who is slowing down and who is speeding up? Okay. Let me go ahead then and let's continue to address this. Slowing down, we already saw this. Object A is slowing down. We see that. How do we know? Negative slope for the negative slope here. And also, if we compare the values, if it's negative slope, the acceleration will be negative. If velocity is positive, opposite signs, object A is slowing down. Who's speeding up? Object B and D. Okay, so B and D are speeding up. Again, how do we know? Positive slopes. Accelerations are positive. Velocities are positive because all velocities right now from this picture we're given, all velocities are positive as well. If the signs are the same, object speeding up. Okay, so we know then that A is slowing down and B and D are speeding up. Okay, and for these reasons, that's why make sure you write down this information here, folks. This information here will give you the answers to all these questions. Okay, I'm sorry for the 4 questions we've answered so far. Okay. All right, let's take a look at number 5. Okay? Number 5 then asks, who is in front at the start of, at time 0 here, at time equal to 0, who's in front? Okay. The answer is we don't know. Remember, we do not have any information about the position of the objects from a velocity time graph. All we know is how fast it's moving at certain time intervals. Okay? We don't know where it's at. So the temptation here to when you're given this graph, the temptation for many students new to physics is that they look at this and they're thinking position time graph instead of velocity time graph. Because on a position time graph, that we learned about about a week or so ago, yes, if all of these started out at 0 here, they would all be starting at the same location. Okay, but this is not a position time graph. This is a velocity time graph. Okay, so at the very beginning here, we have no indication. We do not know where the objects are located. Could they all be starting at the same place? Yes. Could they be staggered in some place? Yes. They could be also in separate locations completely, and we don't know. All we know is that at a certain moment in time that we call time is equal to 0, these objects have a certain speed. So the answer to number 5 then is that it's undetermined. We do not know who's in front or who's not in front, or their positions on it from a velocity time graph. Okay. All right, which leads us to question number 6. Okay, And the question then is, do these objects ever meet? Okay. And again, you have to be careful about this, because when we were talking about position time graphs, we were talking about how if the lines intersect each other, then the objects cross paths. But understand again, what we were given in the position time graph is the positions of the objects. So if the objects cross on a position time graph, they are occupying the same position at a certain time. So yes, they do meet, but this is a velocity time graph. The intersections here do not mean, the points of intersection here do not mean that the objects cross path. Again, the velocity time graph does not give us any information about the position of an object. All it tells us is the velocity. And what do these intersections mean then? It just simply means then at this particular time interval here, where these two lines cross. So if we take a look at this, at this particular time interval here, right here, okay, what we can say then is that both objects had the same velocities. And that's it. And same thing holds true here, that at this position, at this point here, object A and object C had the same velocity. At this particular moment in time, object A and C had the same velocities. Doesn't mean that they are in the same place. At this point here, at this time interval here, we'll call this time 1. At time 2 here, all it simply means then is that object B and object A had the same speed. They had the same velocity. Okay? And at this particular time interval here, and we'll call this time is equal to T is equal to T3. Okay? At this particular time interval here, object B and C had the same velocity, and object A and D had the same velocity. That's what those intersections mean. It does not mean that the objects met. It just means then that at that moment in time, they had the same velocities. Okay. All right. So those are the answers, folks, and we can obtain all that information from this position time, from this velocity time graph here. And so what you want to make sure you do then is that you can, if you weren't quite sure how we got all this information, okay, make sure you come by and you see me, because we have to be able to answer questions like this. Okay? You have to be able to answer questions like these here as you move forward. Okay, as you move forward, and this is basic interpretation of the graph here. Okay. All right, let's go ahead then, and I want to do one last thing here with you involving this graph here, and I want you, what I'd like you to do, and I'm sorry, let me go back up here. What I'd like you to do, sorry, okay. I would like you to pick one of these four objects, A, B, C, or D, and draw a simple picture. So what I'd like you to do, and I'll write this here for you now. I want you to draw a simple picture representing the motion of the object. Okay, so basically do what we did yesterday. Okay, do what we did yesterday, but I just want you to choose one of these. So on your paper right now, I want you to pick A, B, C, or D. It's up to you, whatever you want to do. And I want you to draw a picture, and I'm going to choose one in just a moment for you. I'm going to draw one for you, and then we'll compare answers. But I want you to draw the picture of how this object moves from this velocity time graph. Okay, so take about 30 seconds, 30 or so seconds in order to draw this picture. Okay, go ahead and get that done. All right, so let's go ahead. I'm going to do a couple here for you. Okay, let's do a couple. Okay, let's start out. I'm going to choose A here, arbitrarily choose A. Okay, so let's go ahead and show how A is moving. Okay, so here is object A with mass M. Let's just pretend it's a car. Okay, and here we have it starting out. Okay, here is time is equal to 0 seconds. Okay, so everything starts at 0 seconds. Okay, and so with that said, then let's go ahead and let's plot what we have here. Okay, and so let's show then that at time is equal to 1. We don't know what the time interval is, but at some point is equal to time is equal to 1. Make sure you understand then the velocity here, the initial velocity then is not equal to 0 meters per second. And you could assign a number if you want to. And let's just arbitrarily assign a number here. It's not equal to 0. So let's say then that the velocity here initial is 10 meters per second. Okay, 10 meters per second. So then therefore, by the time we get to the time is equal to 1, this first time interval here, the velocity has to change. it's changing, and we see it changing here. And so my question to you then is, if we chose 10 here, is velocity here going to be greater than or less than 10? The answer then is going to be less. So let's just say arbitrarily then this here is going to be 5 meters per second. So it's slowing down. So at some time interval here, it's going to start, it's going to be less. So it's going to be less than what you start out with. So we're saying here then that it starts out at 10 meters per second up here, and at some time interval here, it ends up at 5 meters per second, okay? And then let's continue on at some time interval of second time interval, second time interval, okay? Okay. The object moves, okay? The object moves, and at this particular time interval, which we call V2, okay, we know then that it's going to be less. So let's say it's down here about 1 meter per second. Zero. Let's say it comes to a stop. 0 meters per second. Okay. And so with that said, then we can calculate for the acceleration here. So this is constant acceleration, so the change has to be constant. Okay. So what I would like you to do here, since I'm running out of time, what I would like you to do, so on your picture, okay, choose some velocities, and then I want you to calculate for the accelerations. Okay. So what I'll do is I will calculate for these accelerations for you tomorrow. Okay. So what I'd like you to do on your picture, whichever one you chose to do, I want you to plug in some numbers, and show then whether the object is speeding up, slowing down, or maintaining constant speed. Okay, so I want you to draw the picture. I want you to finish drawing this picture for tomorrow, and then what I'd like to do is compare some of our answers for tomorrow. So make sure you post the work there, and I'm going to pick a few of these and use them for our discussion tomorrow. So please make sure you understand then, I want you to finish drawing this picture here. I want you to finish drawing this picture for your object, which if you chose object A as well, compare it with what I have here. But you're going to plug in your own numbers. You're going to plug in your own numbers, since this graph here doesn't give us any numbers, and show us then the acceleration. Okay, and then make sure you upload that onto Google Classroom. And I'm going to pick a few of those, and I'm going to share them with you tomorrow. Okay, so I'm going to share them with us as a class tomorrow, and we can see how you folks drew these pictures out as well. Okay, so please make sure you do that, so I have something to use for tomorrow. Okay, so make sure you get that done, and then I will see you folks tomorrow. Okay, all right, very good, folks. I will talk to you tomorrow.